Hello everyone and welcome back to PostNetwork Academy. I am Bindeshwar and today we will explore some fundamental questions based on continuous probability distributions, which is an essential topic in data science and AI. In this video we will cover conditional probability, probability density functions, and we will solve real world problems step by step. So stay with me till the end and don't forget to like, subscribe and hit the notification bell. So first question is that compute the conditional probability. So here it is given that probability of x is greater than 3 upon 4 given that x is greater than 1 upon 2. So this is a conditional probability and probability distribution of x is given. So here we will see that this is like conditional probability. It is a conditional probability that probability of A given B. So I am writing here of A given B. So probability of common elements given B. So probability of A intersection B upon PB. So that is a conditional probability. Now here for continuous random variables, probability is computed using integration. So here probability density function must satisfy the integration from minus infinity to plus infinity. If you integrate, so that would be equal to 1. And area under probability density function curve represents probabilities. So here what we will compute P probability of x which is greater than 3 upon 4 given x is greater than 1 upon 2. So we can write in this way what we have seen in the formula. Thereafter probability density is given. So here fx is 4x cube where x lies between 0 to 1. So now we will calculate. So here PA, if we calculate PA, so that would be A to 1 because here upper bound you can say that is 1. So from A to 1. If you say that x is greater than A, so that means A to upper bound 1. And this is the density function 4x cube dx. So here if we integrate and plug the value, so we will get 175 upon 256. And the same way we will calculate probability of x which is greater than 1 upon 2. Now conditional probability, so that would be basically we are calculating here p x greater than 3 upon 4 given px is greater than 1 upon 2, and that would be this one because that would be equal to probability of x greater than 3 upon 4 upon probability of x greater than half. So just we are plugging the values here, and finally we will get 35 upon 48. Let us see another example, which is example 6 from, if we see the last video also. So the probability density function of 1 liter pure ghee pack is given by here. The most important thing is probability density function and where x lies. So it is from 1 to 1.11. Otherwise it is 0. So that is the probability density function. And what we need to do, we will examine whether the given PDF is valid. So here what we will compute, we'll compute here 1.01, so 1.02, second one, and first question is this one. Second question is we will compute p from 1.01 to 1.02, and secondly we will check that whether this PDF is valid or not. So what we will do, we will integrate from minus infinity to plus infinity, and here basically already interval is given, so we will take 1 to 1.1. We will see integrate, if it comes 1, so that is valid PDF. So let us integrate it. So if you integrate, so what will happen, just x minus 1 whole square and just put the limit. So here 1.1 minus 1, that is, and the second one here 101 minus 1. So finally you can see that here that will become 0, and that would be equal to 100, and if you see that this one 0.1 square, so 100 into 0.01, so that would be equal to 1. That means this PDF is valid. Now let us see, compute between value of x between 1.01 to 1.02. Just we will put this limit from 1.01 to 1.02. We will basically, we are calculating area, and we will get also probability. So if you put the values, so simply you will get this value. You need to consider that you have to take care about this interval. This is very important, and you will integrate. This is the lower limit, and this is the upper limit. So the value would be 0.03. So hope you understood. These are the key takeaways what we have done. For a more videos and resources, you can visit website www.postnetwork.co. You can also visit YouTube channel, Facebook page, and you can follow LinkedIn page of Post Network Academy. So hope you understood. Thanks for watching the video.